goal of this video will be to broaden our perspective of how we deal with kth order reactions. So let's take nth order reactions. So far we have been talking about first order, second order, zeroth order as well, but we never got a chance to talk about what happens if n is a general number. So this video is going to be much less of chemistry and much more of mathematics. So let's begin. So given you have some sort of a reaction wherein A goes to some products, you can write, if it is an nth order reaction, that's what we are assuming here. What you can do is you can write the rate as k times a to the power n. Now, once you do this, once you write the rate to be equal to k times a to the power n, you also need to take into account that the rate itself is equal to negative of d concentration of a over dt. So then you have the differential equation, and the differential equation is negative of dA over dt equals k times a to the power n. Take all the a terms to one side and all the other terms to one side. So that will give you negative of dA over a to the power n equals k dt. One thing you can also do is you can take the negative sign from the left hand side and put it on the right hand side. Once you have done that, what it remains now is to integrate both sides. You are going to integrate both sides. So let me write that expression once again so that it's a bit clearer. And so here you have dA over a to the power n equals negative of, you can take the negative outside, negative of k dt. And the limits of integration, so you start from time being equal to 0 and you arrive at time being equal to a certain number. Let's take capital T. And here the concentration of A, let it start at A naught, the initial concentration, and let it reach at some AT when time is equal to T. One more thing you need to know here if you want to evaluate this integral, and that is that dx over x to the n is equal to x to the power negative n times dx, and that is equal to x to the power negative n plus 1 over negative n plus 1. This stuff right here. So now what you can do is you can write this as a concentration to the power negative n plus 1 over negative n plus 1, and this is going to be evaluated from A naught to AT, and this entire thing is equal to negative of, let me put the brackets here as well, so negative of kt from 0 to t. I always confuse the limits, by the way, but anyways, once you've done this, now what remains is to put everything in. So you have a at time t to the power negative n plus 1, over negative n plus 1, just the same thing, minus a naught to the power negative n plus 1 over negative n plus 1 equals negative k t minus 0. And notice one more thing, and I didn't tell you about this because I wanted to extend the argument a bit. If you had n to be equal to 1, then you would have in this expression right here, you would have x to the power negative 1 plus 1 over negative 1 plus 1, and that would be equal to 1 over 0, and it doesn't make any sense. So in fact, when n is equal to 1, that is the integral of x to the power negative 1 dx is equal to natural log of x, and that's something that we did in first order equations. So here we are already assuming that n is not equal to 1, not negative 1, not equal to 1. Once you've written it like this, you arrive at the following expression, and the expression is a t, a at time t to the power 1 minus n, 1 minus n just right here, minus a naught to the power 1 minus n over negative n plus 1. And if you write that, if you write the right hand side in a simpler expression, that would be equal to negative kt. Now, what you can do is you can further simplify this, and the sense that it makes in simplifying is that a at time t is actually lesser than a at time 0. So what you can do is you can take the negative sign here in the denominator. So negative of n plus 1 is equal to negative of n minus 1. You can write it like that. And this negative sign right here, would go on and change the signs in the numerator. So once you do that, once you do what I'm talking about, you arrive at a naught to the power 1 minus n minus a at time t to the power 1 minus n over n minus 1 equals negative of kt. And this is a really messy equation, and that's why I didn't want to include it into the mainstream equations, but it's a nice place to do some calculus, and it's a nice way to think about what happens in general with reaction rates. What you can also do with n order reactions is you can find the half-life. So if you want to find the half-life for this nth order reaction, whatever number n be except 1, for that you are taking at to be equal to half of a naught. That's what the definition of half-life is. So then if you put that here in this expression, you arrive at a naught to the power 1 minus n, just this thing right here doesn't change, minus 1 over 2 a naught to the power 1 minus n over n minus 1 equals negative kt. And what you can do is this thing, actually the thing right here, this t is actually your half-life. So instead of t, you're gonna write t half, or whatever expression for half-life you have. Great. Now you could have further simplified this, and no one stops you from doing so. So you would have a to the power a naught to the power 1 minus n, and you take that common and you do the following. You write this as 1 minus 1 over 2 to the power 1 minus n over n minus 1 equals negative of k t half, the half-life. And notice and the math is a bit messy here, so you can just skip this video if you want to. Notice that 1 over 2 to the power 1 minus n is equal to writing 1 over negative of 1 minus n, and that is equal to 2 to the power n minus 1. And thus for this expression right here, you could just have written 2 to the power n minus 1. Now what you do, and this would be the final step in this video, and that will be the half-life for an nth order reaction. It is a naught to the power n minus 1, 1 minus 2 to the power n minus 1 over negative k. You take this negative k and you divide it here, times n minus 1. And if you take this negative sign here, this negative sign, and you cancel it with this negative sign and put a negative sign there, you would arrive at the final expression, and the final expression would be that t half, the half-life t, is equal to a naught to the power n minus 1 times 2 to the power n minus 1 minus 1 over k times n minus 1. The math is a bit less fine. It's a bit amusing, but it's a nice application of calculus. It's a nice application of nth order reactions. I'll see you in the next video.